Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today I'm going to be working through a series of 6 problems to help one of my students get ready for his exam. Please put questions in the comments below, and feel free to post more problems down there as well. On to question number 2. For what values of a and b would make the following function continuous? Use proper notation for discussing your reasoning. So I wanted to write out this function here, not just state it, so that we understand what the function is telling us. So f of x is equal to, well, it's a piecewise function, so it's equal to 3 different things. So when x is less than 1, the function is equal to ax plus 2. When x is equal to 1, the function is 5. And then when x is greater than 1, the function is equal to 1 minus bx over 1 plus x. And so what we want to do is figure out how to make this function continuous. If you remember from the discussion, so when we want to talk about continuity, we talk about f of x being continuous at a point a, so at some x value a, when the following conditions are met. The limit as x approaches a of f of x exists, that the function itself exists, that f of a exists, and that the limit as x approaches a of f of x is equal to f of a. So what does this mean? So this means that the limit as x approaches 1 for our problem has to equal f of 1. So this means that the limit as x approaches 1 of f of x is equal to f of 1. So when we write that out, we're going to write it out in notation here. So we want to show that what we want to do is find the limit as x approaches 1 of f of x equals f of 1. And in order to do that, we have to look at the 2 one-sided limits. So we're going to consider. So consider just means we're just going to take a look at them. So we're going to consider the 2 limits. So we'll say consider the limit as x approaches 1 from the left of f of x. When we say consider this, we can go ahead and plug in the function that's going to be to the left of 1. And the one that's to the left of 1, if we go back up and look, that's going to be the ax plus 2. That's the one that's less than 1. So I can replace f of x there with ax plus 2. Because of the nature of the limit, one of the things about limits is that if you can plug in the value into this expression here, so I can plug 1 in here without having any problems, I can go ahead and do so. So I can go ahead and plug 1 in there. So I can say that this is a times 1 plus 2. And so the limit as x approaches 1 is a plus 2. Okay, all right, fine. Now, what do I want that to be? Well, I want that limit. So I need the limit as x approaches 1 from the left to equal f of 1. So I need a plus 2, because that's what the limit was, to equal 5. Because remember, if we go back up to the function again, the function's value at 1 is equal to 5. So this gives me an equation that I can solve. Subtract 2 from both sides, and I get a is equal to 3. Cool. All right, let's do the same thing for the right-hand side. So we're going to say consider the limit as x approaches 1 from the right of f of x. And the one that's on the right is the one with the b portion. So it's going to be 1 minus bx over 1 plus x. And again, I can plug 1 into this because 1 doesn't cause me any problems. So if I plug 1 in, I get 1 minus b times 1 all over 1 plus 1. So I evaluate that, simplify it up a little bit, and I get 1 minus b over 2. Okay. So what do I need for that? So I need the limit as x approaches 1 from the right to equal f of 1. So I need 1 minus b over 2 to equal 5. So solving this quickly, multiply both sides by 2, get rid of that fraction. I get 1 minus b is equal to 10. If I subtract 1 from both sides, I get negative b is equal to 9. And so that tells me that b is equal to negative 9. So for f of x to be continuous, a has to equal 3 and b has to equal negative 9. Thanks, and I'll see you in the next video.